Okay, this will be lesson 3. The standards we're going to focus on is knowing the precise definition of angle. We're going to work on doing construction on copying an angle and bisecting an angle, and we will be using modeling today. So for the first part of the class, I need you to spend 5 minutes, so put the thing on pause, do the opening exercise, make sure you answer in full sentences, verify or prove your answer, and for part B, make sure you use a different colored pencil. Red is great, but anything other than your normal colored pencil, and make sure you use a straight edge. So pause this and then come back in 5 minutes. Okay, what you should have done is the following. So what is special about points D, E, and F? D is a midpoint of CB, which means it is right in the middle and cuts CB in half. So C to D and D to B are the same length. F is a midpoint, and E is a midpoint. Draw DE, EF, and FD. This is the part I said to use a different color, and I'm going to use red because that's what I asked you to use. So draw D to E, draw E to F, and draw F to D, and I said to use a straight edge, so I did. What kind of triangle must DEF be? DEF should be an equilateral. So the first answer here, let's see, first one should be midpoint. This one should be equilateral. I'm not going to fit this. Equilateral. There, equilateral. What is special about the 4 triangles within ABC? So we've got this triangle CED, and it's equilateral. We've got EDF, which is equilateral. We've got FDB, which is equilateral. We've got AEF, which is equilateral. And they are all the same size, so they are all congruent. So they are congruent equilateral triangles. And how many times greater is the area of ABC than the area of CDE? CDE is this small one right here, and ABC is the big one, and there are 4 of them that make the big one up, so it is 4 times. Okay, so then we've got about 5 minutes to go through some definitions. If you need to pause along the way to get these definitions, if you look in your notes, most of them are in there already. Some of them you need to fill in. So angle is the union. Union means putting together. So if you put 2 things together, you get a union of 2 non-collinear. Collinear. So non means not. Collinear means line. So if we want to take 2 rays that are not in a line, and they have the same endpoint. So if I take this ray, and I take the other ray that's over there, and I put them together on the same endpoint, I get an angle. So this is not an angle, 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 and if I take this and join this up, and swing this around, it's saying that's not an angle either, because that would be a line. Okay, so 2 rays, same endpoint, you get an angle. Convex. Convex means only has interior angles measuring less than 180. So this is less than 180, this angle over here is less 180, and this angle over here is less 180. This angle right here, this one, from here to here is greater than 180, so this is not convex because of that angle right there. So convex, not convex. Interior angle is when you have the angle, you've got a small piece and you have a very large piece. The interior is the small piece, the exterior is considered to be the big piece. Angle bisector. So that if to bisect something means to cut it in half. So for bisecting an angle, we're cutting the angle in half, which means that this piece and this piece are the same measure. Notice I put the little tick marks on my arcs. That means that they are the same measure. A ray that forms 2 congruent angles is an angle bisector. Another way to say this is if C, this is C, this point right here, is in the interior of AOB, angle AOB, AOB. So C is on the inside of angle AOB. then measure of angle AOC, the measure of angle AOC has to be the same as the measure angle COB. COB. So again, we're saying that this angle AOC is the exact same as COB, and therefore this bisects. Bi means two, or in this case, to cut in half. So some assumptions that you might want to make. This is going to be 8 minutes long, probably less because I'm going to fly through this. So given a line, the points of a plane that do not lie on the line form two sets called half planes. So we have a half plane. This all up here, this is one half plane cut by this line. And know that we draw lines as ending, but the arrow means that they go on forever. So I could draw it coming off here, or I could draw it going off the edge of my screen over there, okay? But in this case, we just draw the arrows to mean they go on forever. So we could mean this top piece over here, or we could mean this bottom piece down here, and all of this stuff on this side of the line, and that would be another half plane. Okay, so we've got half planes. Such that each set is convex, so this side over here is on one side of the line, so we've got nothing greater than 180 degrees. If P is a point on one of these sets, and Q is the point over here, then if we connect P and Q with a segment, it has to cross the original line we have drawn. That's all we're saying here for this assumption. Second assumption, given an angle AOB, then for any point C in the interior, okay, not exterior out here, interiors in here, so any C inside here, the ray OC, so let's just drop this right down here, and draw a ray OC will always intersect segment AB, and here is segment AB. Remember, rays go on forever, so yeah, I could have drawn this ray with C in here. Grab this ray, come on. I could have drawn it here where it doesn't look like it intersects, but because it's got the little arrow on the end, that does mean that it goes on forever, which means you can just extend it on out here and it will cross that AB. Another assumption, to every angle, AOB, there corresponds a quantity that's the measure of that angle, and we say that the measure of that angle is got to be between 0 and 180 degrees. So the measure of this angle here, notice that our protractor has two sets of numbers. I do not think that this is 141 degrees. I believe that this is actually 39, and you can see it's 39.5 or 38 degrees. So this would be 38 degrees. Okay, so that number has to be between 0 and 180. We don't measure from A all the way out and around and back to B. We never talk about that. We always talk about this interior angle. So we talk about obtuse and acute. Hopefully those are words you know. Obtuse being greater than 90 degrees, acute meaning less than 90 degrees. We got right angles. Just some quick vocabulary for you to remember. They're going to be popping up here and there. Another assumption we're going to make is if C is a point in the interior of angle AOB, then the measure of AOC added to the measure of COB has to be the measure of AOB. That should make sense to you. So if we take angle AOC and we add it to angle COB, you should get the measure of angle AOB, the whole thing. So the black one plus the red one should give you the green one, if we found the degree measurements of those. Okay, another assumption. If you have two angles, angle BAC and angle CAD, okay, here they are. They form a linear pair, so if I slide them together, they make a line, which means linear pair. That means that when you add these two angles together, you have to get 180 degrees. So if the two angles are next to each other, adjacent means next to, that's a good word for you, ADJACEN, adjacent, next to, or sharing a side. So if the two angles are adjacent or next to each other, and they form a line with the two of them, then they are called a linear pair, and they are also supplementary. Okay, if ray OB is a ray on the edge of one half plane H, so here's H, and we use a rectangle or a parallelogram to represent a plane, and so I put this ray OB on there to split my plane. Then for every set R is a measure of degree, there's exactly one ray. So if R were 12 degrees, then I would have one ray at 12 degrees. And there would only be one ray at 12 degrees on a half plane. I could do another 12 degrees, but that would be on the other side of the ray, so it would be in the other half plane. If I said it was, over here, so that's more like 82 degrees, there's only one angle that is 82 degrees that is on that side or that half plane. I could go over here and make it, 82 degrees, and it would be in the other half plane. So you do have two, but not per half plane. Okay, so mathematical modeling exercise 1, you've got 12 minutes, so you'll want to stop the video at this point, and you want to watch this video right here. This video is this YouTube right here. And this is what it looks like. I'm not going to play the video right now. Instead, I am going to put that URL right there. So you want to play that video at that address right there. You want to find the speaker's error, so the person who's talking does make a tiny mistake in there. Try to find that error. Keep the steps in the video in mind, because you're going to need those steps later as you attempt to bisect a angle bisector construction on your own. Things you want to think about are angles the only geometric figure that can be bisected? What determines whether a figure can be bisected? What kinds of figures cannot be bisected? So pause this, go to this web page, and watch that YouTube. Okay, so hopefully you watched that. You figured out that the speaker does make a tiny mistake, and the tiny mistake is they use the word protractor instead of compass in there. Protractor. This is a protractor, and compass. This is a compass. So make sure you know the difference between protractor and compass. So are angles the only geometric figure that can be bisected? The answer to that is no. What determines whether a figure can be bisected? Well, it has to be symmetrical. Okay, so symmetrical. And what kinds of figures cannot be bisected? And that would be non-symmetrical figures cannot be bisected. So to cut something in half and have two equal parts, you have to have some symmetry going on there. Okay, so the next thing you're supposed to do is look at these wood pieces now that you've watched the video and try to figure out how to make these cuts so that the picture frame fits together. So how are we going to make this cut? So spend a little bit of time, see if you can figure that out. Pause the video and work on that. Okay, so to bisect an angle, the way we do that is we're going to take our compass. You're going to put the point of the compass on vertex A. So I'm going to label my vertex A. put my point of my compass on A. I'm going to make a circle centered at A, whatever radius I would like. I'm now going to take and label the intersection of the circle and the original angle rays as B and C. Then I'm going to make a circle centered at B, and I would like that to be a radius. Oops, I need to move this around the other way. Okay, I'm going to put it centered at C, and I'm going to make it radius CB, and I'm going to draw a circle. And then I'm going to center at B and make a circle with radius BC. And now my circle C and my circle B, the two green ones, intersect at two places. And I'm going to label the one that's on the interior of my angle D. Oops, D. So now that I've labeled that D, I am now, the last step of this is I'm going to just draw ray AD. And I have now bisected my angle. So what are those steps? First, label the vertex. Let me dual screen this. Label the vertex angle as A. Then I drew circle A, centered at A, with any radius I wanted. Then I labeled the intersection of circle A of the rays of the angle as B and C. So I labeled that point B and that point C. Then I drew circle B, centered at B with radius BC. Then I drew circle C, centered at C, radius CB. And then you know that one of the two intersection points is on the interior of the angle, and I'm going to take that and I'm going to label that intersection point D, and then I'm going to draw AD to bisect my angle. Okay, so then I want to do the same thing again with this new angle, just for practice. So label my vertex A, draw circle A, label my intersections B and C, draw circle B with radius BC, draw circle C with the same radius, that BC. Label the intersection that's on the interior, D. And then draw the ray from A through D. And I'm off just a little bit. There we go, that's better. Okay, one more time. I'm going to label my vertex A. I'm going to put a circle centered at A with any radius. Going to label my intersections with the circle and the angle as B and C. Going to make a circle centered at B with radius BC. Going to make a circle centered at C with radius CB, which is the same exact one, same exact radius, so I don't adjust my compass. I'm going to take and label my intersection D, and then I'm going to draw ray AD. And now that angle has been bisected. So how does the video method of the angle bisector construction differ from the classes method? Take a moment, think about that. Also think about if there's fundamental differences, or is the video method simply an expedited form, a simpler form of the class method. So take a moment, jot down your answers to those two questions, come back, get the answers. So basically the two methods are very similar, if not the same. Again, it's just, yeah, one is expedited or more simple than the other one, but that's the same method. Do you notice any symmetry with your drawing so far? So if we look at our drawings, this BAD and this DAC, you should see that the bisector actually is a line of symmetry. So if I folded along this ray, they should, the two sides, the two rays, AB and AC, should line up. Same thing here, AC and AB would line up if I folded on D. So that would be my line of symmetry. This would be a reflection. What happens if you reflect the angle across the bisecting ray? So if I reflect this, then C ends up where B is, B ends up where C is, and you basically have the same exact angle, just flipped. Okay, mathematical modeling exercise 2. You've got 12 minutes to complete this one. You're going to take the handout, or I think it's in your book that you got. It's a sorting activity. Cut them apart, sort the steps into what order it would take to copy an angle. And then once you get them in order, actually try it and see if you are copying an angle, and fix it along the way if you seem to have some steps out of directions. So take a moment and do that. Come back to the video when you're done. Okay, so to copy an angle, first of all, you have your original angle. I'm going to label that point, and I'm just going to go here because I believe that I've got different letters going on here. So label the vertex of my original angle as B. That's what you should have picked as the first step. Draw EG as one side to be drawn. So I'm going to take my ray tool, and I'm going to draw, I want that to be a little bit bigger, ray, put an end point on there and another point on here. So that is ray, EG, E is on the end, G is the one in the middle, so this is E here, and this is G over here. And the next step you should have come up with was draw circle B, centered at B, any radius. So draw circle B, centered at B, any radius I want. The next step is label the intersection of circle B with the sides A and C. So A, put that one there, C, put that one over there, and those are my intersections, and I can put some points there if I'd like. Points right on the intersections, so point A and point C. Next step you should have picked out was draw circle E, centered at E, and you want the radius to be BA, so I want to keep the exact same compass setting, BA, come down to E, and draw a circle with the same radius. Label the intersection of circle E with EG as F, so I'm going to label that as F. Okay. Draw circle F with radius CA, so I'm going to have to go back up. I need to adjust my compass here. So it is the distance from C to A. Then I'm going to come down and draw circle F with that compass setting. And then I'm going to label either intersection, doesn't matter which one. So I've got an intersection up top and I've got an intersection down below. So I'm going to label my intersection here as D. and then I'm going to draw ED. So grab my ray tool and draw ray ED, and I kind of missed, so let me go back and fix that. And you should be using a straight edge for all of this. And there is ED. So I have now copied my angle. The angle ABC should be the exact same measure as DEF or DEG, whichever way you want to call that one. We've got a few more definitions here. Midpoint. We talked about midpoint earlier in this class. So point B on a segment AC, so here's segment AC. B is between A and C, and AB is equal to BC, so it has to be right here on the line so that this distance from A to B and this distance from B to C are the exact same distance. Between means on the same line, so this is not between. B is not between A and C here. B is not between A and C here. You have to be on the line to be between. You also have to be between A and C, so this is not between. B has to be somewhere in here along this line to be considered between by definition of between. Degree. Degree is when you divide up a circle into 360 equal parts. Each arc is going to be considered 1 degree. So 1/360th of a circle is a degree. And we use degrees to measure angles, arcs, and rotations. So just because you have a degree does not mean you have an angle. You could be talking about an arc or a rotation. Zero angle. So a zero angle is just a ray. So if I've got an angle that's measure of degree 0, that means I'm here, and we just have this ray. If I've got a straight angle, I have a line. So 180 degrees, I just have a line. There's not really an angle here. So a zero angle is just a ray, and a straight angle is just a line. Okay, so the last thing to do is your exit ticket. You've got 3 minutes, so pause the video. Make sure you justify your response, show all your work. This is not just a yes/no question, so do everything you need to do to justify it. So in 3 minutes, come back and turn in your exit ticket. And then for homework, you're going to do the problem set, and you should have a crossword puzzle with the vocabulary from this section, making sure you're keeping up with your vocab.